In 4.17, we have been provided with the first and the last terms of the arithmetic progression. The first term is -4 and the last term is 146. The sum of the terms is 7171. The number of terms, or n, which is we are supposed to calculate. We know that s is equals to half into n into a plus l. So it will be 7171 is equals to half into n into a, which is -4, and l, which is 146, which will be 7171 is equals to 146 minus 4 is 142, divided by 2 is 71, n plus 71. So n will be 70, this is multiply, n will be 7171 divided by 71, which is equivalent to 101. So answer for 4.17 is A. 4.18, if you save 1 paisa today, 2 paisa the next day, which is the double of the first day's deposit, 4 paisa the succeeding day, which is double the second day's deposit, and so on, then your total savings in 2 weeks, 2 weeks has 14 days, will be. So basically we have the first term as 1, and our R, or common ratio, since the amount is increasing, not with a common difference but with a common ratio, so our R will be 2 over 1, which is second over first term, and which will be 2 again. We have 14 days in 2 weeks, so n will be 14, and we are supposed to calculate the total amount which we will save, which is the sum of first 14 terms in a geometric progression. S is equals to A R power n minus 1 divided by R minus 1. This will be 1 2 power 14 minus 1 divided by 2 minus 1. So 2 power 14 is equal to 16384, minus 1 is 16383, and this amount which we have calculated 16383 is in paisas. There are 100 paisas in 1 rupee, so we will divide this by 100, and this will be 163.83. 4.18 answer will be C. 4.19, a person is employed in a company at 3000 per month, and he will get an increase of 100 rupees per year. This means that in year number 1 his monthly salary will be 3000, and there are 12 months in 1 year. Therefore his total salary for year number 1 will be 36,000. He will get an increase of 100 per year. His salary will get to 3100 in year number 2 per month, and again there are 12 months in a year, so his salary for second year will be 37,200. The total amount which he receives in 25 years, so this will keep on increasing. For example, in year number 3 it will be 3200 into 12, and 3200 into 12 is 38,400. The total amount which he will receive in 25 years and the monthly salary in the last year. Well, for the total amount we can say that this is the first year's salary, or this is our A, which is 36,000. In each of the years the salary will increase by a common difference, which is 1200. In each of the years, if you see, the salary is increasing by 1200, so our D will be 1200. We have to calculate the total salary, or the total amount he will receive in all 25 years. So actually we have to calculate sum of year 1 salary plus year 2 salary plus year 3 salary and so on till year number 25. So our sum will be S is equals to half into N, which is 25 or 25 years, into 2A. A is 36,000 plus N minus 1, which is 25 minus 1, into D. D is the common difference, which is 1200. If you solve half into 25 into 2 into 36,000 plus 25 minus 1 into 1200, it will be 1,260,000. So looking at the options, we can say that A cannot be the possible answer. The answer will either be B, C or D. Now if we check what will be our answer, it further says that the monthly salary in the last year. It also wants us to calculate the monthly salary in the last year. The monthly salary cannot be 540, since the salary in the first year was 3,000 per month, and if it is increasing by 100, there is no chance that it can go to 540. So we can say that B is not the possible answer, A is not the possible answer. Now we are left with C and D. Now to calculate the monthly salary for the last year, we can say that the monthly salary in the first year was 3,000 and it keeps on increasing by 100 in each of the years. So the monthly salary in the last year will be the 25th term, where A is 3,000 plus N minus 1 into D, which is the salary increment. So our answer will be 5,400, and therefore the option D could be selected. 4.19 will have answer D. Next question, 4.20. 4.20 says that a person borrows 8,000 rupees at 2.76% simple interest per annum. The principal and the interest are to be paid in 10 monthly installments. If each installment is double the preceding one, the value of the first and the last installments are: a person borrows 8,000 at 2.76% simple interest per annum. The borrowings are at a interest rate. The principal and the interest are to be paid in 10 monthly installments. Well, if each installment is double the preceding one, this specifies that the progression is not an arithmetic progression, it is a geometric progression, since the terms are the twice of the previous one or the double of the previous one. Furthermore, the total amount which needs to be paid will be, if we calculate the interest first, which is I is equals to PRT, the interest for 10 months will be 8,000 into 2.76% into 10 over 12. And if you calculate 8,000 into 2.76 divided by 100 into 10 over 12, it will be 184. So the total amount is the principal amount of 8,000 and 184 of interest, which is 8,184. In totality we have to pay this amount. It says that if each installment is double the preceding one, therefore our R will be 2. The value of the first and the last installments. If we calculate the value of the first installment, we know that S is equals to A R power n minus 1 over R minus 1. The total amount to be paid is 8,184. First installment is A, R is 2. Since there are 10 monthly installments, we have n as 10 minus 1 divided by R minus 1 or 2 minus 1. This will be 8,184 4 is equals to 2 minus 1 is 1 and 2 power 10 minus 1 is 1023 A, and A is therefore 8184 divided by answer, which is 8. So our A or first installment will be 8. We can eliminate option number C, and the last installment will be the 10th installment. So our 10th installment or 10th term will be A plus n minus 1, or this is a geometric progression, so our 10th term will be A r power n minus 1. Our 10th installment will be 4096. So looking at the options, our answer should be 4.20A, which is that the first installment will be 8 rupees and last installment will be 4096 rupees.